everyone, Dr. Crehay here. In this video, we're going to talk about type 1 error, type 2 error, and power. What are they? What do we need to know about them? How can we avoid them? How can we use them to our favor? Remember that we're using hypothesis testing so that we can go from a small sample of data and generalize to the larger population. So again, we have a research question, we have a hypothesis about how things play out. But unfortunately, we just don't have the resources, we don't have the time, we don't have the money, we don't have the manpower to go out and ask every single person that we're interested in, or observe every single person that we're interested in. So we instead take a sample of those individuals and then we use inferential statistics to generalize to that larger group, that larger population. Because we are looking at a small piece of the bigger picture, we can sometimes make mistakes. These are where our type 1 and type 2 errors come in. Now, we need to try to anticipate these errors, we need to plan for them, we need to try to reduce the possibility of these happening. We have to prioritize in our research studies if type 1 is more problematic or type 2, and we'll talk about that in just a second. But we need to try to anticipate these, we need to plan for them, and we need to reduce them as much as is possible. So what are they? What is type 1 error? What is type 2 error? So I've actually copied this supplementary table. If you've taken research methods with us through the psychology department, we use a fantastic textbook from a woman, Dr. Beth Morling, Research Methods in Psychology. This is from the second edition. In my version of this book, it starts on page 464, and then I pulled this table from page 469. So if you have that textbook and you want to read the supplemental section and then come back to this video, if you want to look at the table in your textbook, if you still have it, please feel free to do so. Otherwise, I've got it right here for you. I just think this is a more straightforward way than how our statistics book is talking about it, unfortunately. Anyway, so we have 4 possible decisions that we can make within a hypothesis testing framework. We could claim that there is an effect when there is actually an effect. That is a correct decision. We could retain the null or fail to reject the null when there really is no effect in the population, which is our other correct conclusion. We're not worried about these, right? We want these things to happen, so we don't have to kind of have a plan B about them. We could, though, also have a type 1 or a type 2 error. So this table we have here, so it's showing in columns the true nature of the population. So if we could know what the real effect is, and then along the left there, the decision based on the sample. So what if in the real world there is really no effect? There's no effect in the population, but the decision that we make based on the sample, we reject the null hypothesis and conclude that there is an effect. So with a type 1 error, we're concluding that there is an effect when there actually is not an effect. So to put it a different way, we're rejecting the null. Remember, the null will claim no relationship, no difference. We're rejecting that null when it should be true. So we are claiming that there's an effect when there really isn't an effect. So that's a type 1 error. We could also have a type 2 error. So this is in the lower right hand of our table here. So in the population, there really is an effect. So the effect exists, the difference is there, but based on our sample, we decide to retain the null, to fail to reject the null. So basically we say there's not enough evidence of an effect to claim that there's an effect, so we're going to say there isn't one. So that's type 2. So there is an effect, but we claim that there isn't. Type 1, there is no effect, but we claim that there is an effect. Now, depending on your research scenario, these two errors we'll take, sometimes one will be more important than the other. Sometimes you'll want to make sure to avoid one of them over the other. And we'll talk about that in a few examples as we move forward. So again, this is a supplementary table from our research methods textbook if you want to follow along in the actual textbook, and you have that, go ahead. Otherwise, I'm just looking at this table S2.2. So we're dealing with type 1 versus type 2 error. Say we have a research question. Our friend Sarah claims that she can visually identify smart people. So she can pick smart people out of a crowd. So then we come up with a null hypothesis that she cannot. The alternative hypothesis would be that she can identify smart people, and we have 4 possible decisions that we could make after going through hypothesis testing framework. Of course, we have the 2 correct conclusions. We could conclude that she can identify smart people when she actually can, so that's in the top right there. In the bottom left, maybe she really can't, and we decide that she can't, and that would be another correct decision. What if she could actually identify smart people, but we can't gather enough evidence to show that she can? So we decide that she cannot. That is a type 2 error. So Sarah can identify smart people, but we have failed to show it, and that's our type 2 error. Type 1, on the other hand, we would conclude that Sarah can identify smart people, but in reality she cannot. So it's kind of a false positive there, right? So we say that she can, but she cannot. So this is type 1 error versus type 2. What if we have a situation where we have a drug that we are claiming can improve the symptoms of schizophrenia? So our research question is just that. Our null hypothesis would be that the drug does not have any change, does not improve the symptoms. Our alternative would be that the schizophrenia does get better because of the drug. And of course we have 4 decisions here. Top right, lower left cells there, we make a correct decision. We conclude the drug works, and in reality it does. Lower left, we've shown that the drug works, but in reality it doesn't. Then we have our I misread that. We're talking about correct decisions. So lower left, we say that the drug does not work, and it actually doesn't work. So moving on to the errors there, we have type 2 in the lower right. So maybe in reality the drug does work, but we fail to show it based on our sample. Type 2. The drug really does work, but we failed to show it. Type 1, on the other hand, we conclude that the drug works. We start selling this drug to people, but in reality it does not. So that's type 1 versus type 2 errors. What are the consequences of these errors? So why does it matter if we make a type 1 error, if we make a type 2 error? Say that we are medical researchers and we are working on a drug trial. So this drug is supposed to lower blood pressure, but we're concerned that it may cause cancer. So we have 2 hypotheses here. We have a null hypothesis, basically saying that the drug is safe, it does not cause tumors. So we have a little bit of operational definition here, that the tumor rate in treated animals is less than or equal to 10%, but overall our null hypothesis here is stating the drug is safe. Our alternative hypothesis is that the drug is not safe. So the tumor rate is more than 10%, the drug is not safe, and we want to know, type 1, type 2, what are the consequences of these errors in this situation? Now, type 1 error, and I know this is confusing. In fact, to be completely honest, I'm reading from my notes right now. I'm not going to ask you to differentiate between type 1 and type 2 from memory. Please use your notes, use your textbook, use these lectures as resources. But type 1, we claim that the alternative hypothesis is true when in reality our null hypothesis is true. So in this scenario, that would mean concluding that the drug is not safe when in fact it is. The result of this would be that we have a drug that lowers blood pressure, right? So we're saying blood pressure leads to heart attack, leads to all of these negative health consequences. We have a drug that helps that. It helps alleviate that problem, but we're concluding that the drug is not safe. We will not sell this drug because our study has shown, has suggested to us that it is not safe. In reality, it is. We have made an error that is preventing this medication from hitting the shelves. Type 1 error. A type 2 error in this situation, so in type 2, we would claim that the null is true, when in fact the alternative is true. So here we would conclude that the drug is safe, when in fact it is not safe. So here we would market this drug, we would sell it, we would give it to doctors to start prescribing people, and it would cause cancer. So this is a bigger problem. In this research scenario, type 2 would take precedence over type 1. So you would have to plan your research study accordingly. Now, we're not going to get into significant detail about that because it's a statistics course, not a research methods course, but I would like for you to know we have these two kinds of errors that we can make. Sometimes type 1 will be a priority, sometimes type 2 will be a priority. In this case, type 2 is definitely our priority. We do not want to give people cancer. I think it would be better to withhold this potentially effective medication rather than give it to people and give them cancer. So how can we decrease these errors? There are a few things that we can do to reduce error. So again, remember, two types of error. Sometimes type 1 will take precedence, sometimes type 2, depending on your research scenario and those consequences. But across the board, we can do things to minimize error. One thing we could do is to increase alpha. So remember that magical p-value, p is less than 0.05. We could make that larger, and that would help us to decrease our type 2 error. Now, in reality, I would not recommend doing this. You won't get published. You won't be taken seriously. That 0.05 alpha level is pretty strict, but statistically, that would decrease your type 2 error. One thing you could do is to increase your power. We'll talk about power in just a second, but the easiest way to do this would be to increase your sample size, collect more data that will give you more power. And we'll talk about power in just a second, so you shouldn't know what that is just yet. In the next slide, I'm going to give you a picture that talks about these errors in a slightly, more user-friendly way, and then we'll push on to our discussion of power. So this image gives us the 4 possible decisions resulting from hypothesis testing. So you can see again, we have 2 accurate decisions. When our research decision models reality, then we are happy, as this image shows. We could have type 1 error. Again, type 1, we claim that the alternative is true. In reality, the null is true. Or we could have a type 2. We claim the null is true, but in reality, the alternative is true. I just pulled this off of a Google image search, so if that helps you, go ahead and do that search and pull it and keep it in your notes, or you can just jot it down into your notes right now. Alright, so what is power? When we're talking about research, when we're talking about statistical power, what is it? This is the chance of finding an effect if an effect is present. There are a handful of things that will influence your power. Sample size is one, effect size is another, and your alpha or your p-value is another. So if we increase our sample size, we increase power. If we have a large effect size, our power will be higher. And if we increase our alpha, which again, in reality, we can't really do that because of just kind of industry standard, I guess I'll call it. But if you did, statistically, this would increase your power. So let me go through this metaphorically for a moment. So say that I put you in a completely light-proof room. So this room is just pitch black. You can't even see the 2 hands in front of your own face. Now we're going to have 2 things. We have power. I'm going to represent power with light. So in high power situations, I'm going to give you an overhead light. In low power situations, I'm going to give you a tiny little flashlight. So power equals light. We'll also have an effect. So in statistics, the effect will be that we find a relationship, we find a difference, those kinds of things. In this metaphor, my effect is going to be an image that I've hidden on this screen somewhere. So we have the question, do we have an effect? We get to shine a light in one place on this screen to look for the effect. We get one shot, we get one statistical test to look into this data. Say that you have low power, so maybe you've only collected data from 5, 6, 7 people, and you're looking for an effect in this room. So this light space that you see here is where we pointed our tiny little flashlight representing our low power. We did not find our effect. So in this case, low power, our p-value would be greater than 0.05. We would have to conclude that there is no effect present. That may be the case, or we could be making an error here because of our low power. Now, what if in this same room you did your study and you had high power? So say same research scenario, or in the same pitch black room, the only thing that has changed, perhaps you've collected data from 1,000 people, so you have high power, and look at right here, here's my little fallout guide, that is our effect. With high power, we flip on those overhead lights. If there is an effect in this data, if there is an effect in this room, we will find it. P will be less than 0.05. Now I have a small picture here to represent a small effect because in the real world, if you have a small effect, and often in the social sciences we are dealing with very small effects, right? There's small differences, there's small relationships, behavior is very complicated, so we tend to find small effects. You need high power to be able to find these things. You need large sample sizes, those kinds of things. So power is the ability to detect an effect if an effect is present. Now, power, things that influence power, your sample size, the size of the effect you're looking for, those kinds of things determine how large your metaphorical flashlight is. So theoretically, even with a small effect, if you have high power, you turn on those overhead lights, you're going to be able to find your effect. Say we're in a completely dark room, new research scenario, do we have an effect here? So again, we're dealing with a small sample size, we're dealing with low power, our metaphorical flashlight is very small, we shine it one place, we do not find an effect. What if we had high power? So if there's an effect in this room, high power is going to find it, right? So let's flip on those overhead lights and see if there's an effect present in this room. So in this situation, we have high power, we've collected a lot of data, we flip on those overhead lights, we're looking around for our effect, and we can see there is actually no effect here. So our p-value is greater than 0.05, we have to conclude there's no effect. So this is just to make the point that just because you have good power, you're not going to find something that doesn't actually exist, right? Well, you could with some data manipulation, but that's probably a topic for a little bit later. So if you have high power and there is an effect in the room, you will be able to find it. So when you're planning your research study, and I'm not going to make you do this in this course, I think that's a graduate level sort of thing to deal with, but you can calculate power before you conduct your study. You can identify the size of your effect, you input what statistical analyses you'll be doing, and it will tell you what sample size you need. So it will say you need to collect data from 300 people to be able to find this effect with this statistical test. On the other end of things, some people will run power after the fact. So this is called post hoc meaning after. Post hoc power is sometimes referred to as an autopsy. So say you run a study and you didn't plan it out very well, you didn't do your power, maybe you didn't have time, but you didn't find an effect, and you want to know after the fact, did I have the power to find this? In that case, you can input the size of your effect, your statistical tests, your sample size, those kinds of things, and it will give you a number, a statistic representing your power, and you can see statistically, did you have high power in that study? Did you have low power? This is considered an autopsy because you can kind of start to tell where things went wrong. So if you did this study and you had really low power, that might give you some evidence that you should regroup, redesign a little bit, and redo the study with perhaps a larger sample. If you didn't find an effect and it turns out that you had really high power, you probably want to change gears a little bit because there really is no effect, there's no difference, there's no relationship in the population. So power can be really excellent. It's really best used as a tool in the planning stages of research, but you can also use it after the fact to decide what went wrong. So a quick summary of what we've discussed here: type 1 error, type 2 error, and power. Really quick summary is that there are a lot of things to take under consideration when you're designing a research study, when you will be using hypothesis testing. You have to be mindful of errors, and you have to play out what the potential consequences of a type 1 error will be, what the consequences of a type 2 error will be, and then depending on which consequences are worse, do your best to minimize the chances of making that kind of error. The other kind of take home from this lecture is that you have to plan ahead when you conduct a research study. You want to maximize your power, increase your sample size, you want to minimize your errors, try to avoid them altogether if you can, if you're dealing with drug trials and all of those kinds of things. So a lot of this, it just occurred to me, I am talking about, if you're going to conduct research, those kinds of things. This is important stuff to know as you are reading research as well. You want to know, did the researchers plan ahead for these kinds of things? Were they cognizant of type 1 error, type 2 error? Did they do any power calculations? What kinds of things did they think about up front? Did they look at things after the fact? Did they just completely ignore the types of error and power altogether? Which oftentimes they do. So these are some considerations to go along with hypothesis testing. If you can get the general, there are 4 decisions you can make in hypothesis testing. 2 of them are correct, 2 of them are incorrect, and then know where to go find what type 1 is, what type 2 is in your textbook. Highlight it in your notes, whatever you need to do, and then know what power is, what it does, and then the things that influence power. That's really what I'd like you to take away from this lecture. Let me know if you have questions, comments, if you're confused about anything in the little comment bar I'll put up in a second, and I will try to address those to the best of my ability.